So it turns out that just because we're given 3 segments doesn't mean that those 3 segments can necessarily make a triangle. Specifically, we call this the triangle inequality theorem, and what it says is that any 2 sides of that triangle need to add up to a number that is greater than the third side. I usually kind of take a look at these pictures down here and imagine a gate to figure out why this is going to work. So for example, let's start at the far right. Let's say we have this gate, this opening in a fence that's 5 spaces 5 feet long, and 2 of the pieces of our gate are 3 feet and 2 feet. If you imagine those gates swinging closed, they're going to close and make that exact straight line again, which is great if you're trying to make a gate, but not so much if you're trying to make a triangle. The reason it doesn't make a triangle is because the 2 shorter sides, the 3 and the 2, do not add up to a number that's bigger than the third side. If you imagine another example right here in the middle, imagine the 2 sides of that gate are 2 feet and 2 feet. They're going to close. They're not even going to make a complete sealed gate, let alone a triangle, again because the 2 sides, 2 and 2, do not add up to a number bigger than 5. Our final example to look at on the far left over here, we've got legs of a gate, or legs of a triangle, or sides of a triangle. There are 4 feet and 2 feet. If you try to swing those closed, they're not going to close completely, which is bad if you're making a gate, but really good if you're trying to make a triangle. So basically what we're going to be looking at is we want to make sure that the sum, when we add up the two smallest sides we're given, again, have to be greater than that third side. As long as that's the case, we can go ahead and make a triangle. So for example, if we look at these problems along the bottom, we want to figure out if these 3 sides could make a triangle. Our first example's got sides that are 4, 6, and 9 units long. Take the 2 smallest sides, which in this case are 4 and 6, add those together. They have to add up to a number that is greater than the biggest side, or bigger than the biggest side. 4 plus 6 gives you 10, and of course 10 is bigger than 9. So yes, it turns out that those 3 sides could be used to make a triangle. When the directions say to explain, you can't just say yes or no, you got to show how you know it. In this case, our work can just be our proof. Second example, same idea. We want to make sure our 2 smallest sides add up to a number bigger than the biggest side. So just be careful in case they're not in the right order, or like increasing order from biggest to smallest. My 2 smallest sides are 10, so add those together. They must add up to a number that's bigger than the biggest side. 10 plus 10, of course, gives you 20, which is bigger than 15. So yes, those could also make a triangle. Yay. Finally, be careful on this one. We've got sides that are 3, 4, and 7, and we want to see if those can make a triangle. My 2 smallest sides are 3 and 4, so we'll add those together. They have to be bigger than the biggest side, which is 7. What happens that's interesting and you have to be careful of is 3 and 4 give you 7, of course. And then the question is 7 greater than 7? And no, 7's not greater than 7. 7's equal to 7. So in this case, no, that's not going to make a triangle. Those 3 sides will not make a triangle.